This slide represents the classification of aircraft structures, airframes, based on their load-carrying importance and functional role. Aircraft airframe structures are divided into primary, secondary, and tertiary structures. Primary airframe structures are critical load-carrying components. Failure of these structures can directly compromise the safety of the aircraft. Let us look at some of the components of primary structures. The fuselage is the main body of the aircraft. It houses the cockpit, passengers, cargo, and many onboard systems, and transfers loads between the wings, empennage, and landing gear. Wings generate lift and support control surfaces, fuel tanks, and sometimes engines. They carry major aerodynamic and structural loads during flight. The empennage, or tail assembly, provides stability and control. It includes the horizontal and vertical stabilizers and carries aerodynamic loads from control surfaces. The landing gear supports the aircraft during taxi, takeoff, and landing. It absorbs landing impact loads and transfers them safely into the airframe. Nacelles house the engines and systems. Pylons, or struts, are highly engineered brackets that attach the heavy dynamic engine loads into the wing or fuselage structure. Secondary airframe structures carry less critical loads and do not usually cause immediate structural failure if damaged, but they still contribute to strength, functionality, and aerodynamics. Fairings are streamlined covers that reduce aerodynamic drag and protect underlying structures or systems. These allow entry and maintenance access to aircraft systems while maintaining structural continuity and pressurization. Interior structural elements support cabin floors, seats, and internal fittings and help distribute local loads. These include components such as flaps and spoilers that assist in lift control, drag management, and maneuvering. Tertiary structures are non-load-bearing or lightly loaded components. They primarily serve functional, protective, or comfort-related purposes. Interior panels provide cabin enclosure, aesthetics, noise reduction, and environmental separation. This includes seats, overhead bins, partitions, and galleys designed mainly for passenger comfort and usability. Radomes protect radar and antenna systems while allowing electromagnetic signals to pass with minimal interference. Lightweight panels that allow inspection and maintenance access without contributing significantly to structural strength.